Imagine building an app once and running it flawlessly anywhere, on any operating system, any cloud, your laptop, or a massive data center. That's the magic Docker brings to the modern world of software development and DevOps. Docker eliminates the age-old headache. It works on my laptop, but not on the server. Whether you're a developer, a cloud engineer, or just starting your tech journey, understanding Docker is a must-have skill. So let's break it down, from zero to advanced basics, step by step. What is Docker? In essence, Docker is a containerization platform. Think of it as a powerful toolkit that lets you box up your application, together with all its dependencies, libraries, runtime, and configurations, into one self-contained package called a container. Now, this container is portable. You can run it anywhere: Windows, Linux, Mac, or cloud platforms like AWS, Azure, and Google Cloud. Docker guarantees your software behaves the same way, every time, everywhere. Why do companies use Docker instead of classic installation methods? Because traditional setups bring chaos. Different operating systems, varying dependency versions, conflicting configurations, and endless deployment time. Docker solves this with a consistent, lightweight environment. Applications start faster, scale easier, and integrate perfectly with CI/CD pipelines. That's why most modern companies depend on Docker. But how is Docker different from a virtual machine? Picture a virtual machine as a whole computer, an OS inside another OS. It's bulky, slow, and resource-hungry. Docker, in contrast, runs containers using the host OS directly, skipping the unnecessary overhead. Containers launch in seconds, use less RAM and CPU, and make everything more efficient. Let's clarify the main types of Docker tools. At its core is Docker Engine, the main software that pulls images and runs containers. For Windows and Mac, Docker Desktop provides an easy graphical interface. Docker Hub, like GitHub for Code, is an online registry where you find and share container images. Docker Compose lets you run multi-container setups, say, a front-end, back-end, and database, with a single command. And Docker Swarm helps manage many containers across a cluster. Today, many also use Kubernetes for this orchestration layer, but Docker remains the foundation. Now, on to essential Docker terms. A Docker image is your blueprint, a snapshot of your app plus everything it needs. For example, Node, 18 or Python, 3.11 are images. When you run an image, it becomes a container. Think of the image as your recipe, and the container as the finished dish. The Dockerfile is where you write instructions to build your image, choosing a base, copying code, installing dependencies, and starting services. Volumes let containers store data permanently, so important files, databases, or logs survive even when containers end. Ports connect your isolated container to the outside world, mapping internal app ports to your computer's ports. For example, running web servers on 3000 or 8080. Learning the basics is as simple as a few commands. Check Docker version. Docker version. Pull an image. Docker pull nginx. Run a container. Docker run d, p8080:18 List running containers. Docker ps. Stop or remove containers. Docker stop, Docker rm. List and remove images. Docker images, Docker rmi. These let you set up and manage containers hands-on. So where is Docker used in real life? Deploying web applications, running databases instantly, building microservices, automating with CI/CD, and scaling workloads in the cloud. Everywhere fast, reliable, repeatable environments are needed. In short, Docker is the backbone of today's tech infrastructure. By now, you should feel the power of Docker, clear, approachable, and ready to dive deeper. If this helped solidify your understanding, don't forget to show some love. Want a deep dive next time into Docker Compose and Docker files, with real-world demos? Let us know. Thanks for listening. Your journey with Docker has just begun.